Hi, your host Chandrakant is here. Today we are going to solve a problem binary search. 90% of the beginners get edge cases wrong usually. So in this video, I'm going to let you know not just how it works, but why that particular algorithm works. Okay, I'll help you to means I'll share a variation. With that variation you can solve multiple binary search problems. Okay, so let me build some intuition first about binary search and then how it works and its mental model. We are going to deal with that and variation about it. Okay, so what is binary search, right? Everyone knows that there will be a workspace that is divided into some array or some sorted array or something. Now, what binary search says is, let's say we have a dictionary of 1,000 pages. Okay, we have a dictionary of 1,000 pages and you want to go to some X page, like let's say you want to uh, means search for a word which is within that dictionary. Let's say you are searching for a word get, and that word will be in between A to Z somewhere, right, in dictionary. So you need to find that word get. To basically get that word get, you need to first go somewhere and look where that get word can be. So what you usually do, you go some A, you scroll all A, then go to B, then C. Like that, if you go, it will be a linear search. You'll be searching many pages and keep on scrolling. That is just waste of time. You don't have to do that. What we can do is, like, we can go to randomly a page and analyze whether that word get will be in the left of the particular page we landed or in the right of that particular page we landed. Okay, so let's say we started between any alphabet, in between A to Z. Let's say we went to P. P resides somewhere here, and you were searching for G, but G will be in the left of P, not in the right of P. So you don't have to explore this part, right? You just have to explore this part, and in this section, you'll be getting that word get, right? So this is how binary search works. Means, yeah, you are able to divide your search space in such a way that half of the search space gets eliminated. If you see in real world, you're not actually divided that page into two half. In real world, what we actually performed is, we chose a random page or randomness in our mind, and we just opened a page, and there you saw that P exists, so you went left. But here, randomizing that stuff could be in terms of computer. If randomize works like first A, then B, then C, then that could lead to a linear search that we don't want to do. So that's why what we are going to do, we are going to calculate middle element and then divide our search space into two part. After dividing, we can surely discard half of the part and keep analyzing in the half of the part. So you know how the binary search works, right? But the thing is, why every time this particular solution will work, that needs means one need to ask that question, right? So there are some constraint with the binary search. Like, if this particular stuff, you can see here, I'll show you. If this particular stuff is a search space, you are always dividing your search space into two part. Now here, one thing you can notice, that every time your search space is in between left and right. We means we are taking left as one and right as 1,000. We are not exceeding, or yeah, we are not going left of this range or beyond the right of this range, right? So this is the first constraint, that left and right needs to be inclusive. In case of exclusive, there are other ways, but right now I'll tell you, in the case of inclusiveness, what you need to do. Okay, so now you know that your search space is in between left and right. So what you need to do is, you need to divide it into two part. That is, you need to calculate mid of your array and divide that into two chunks. So if you see right now, if you'll calculate, the mid is equal to right plus left by 2. You are just calculating average, means not exactly average, but the thing is, you added left and right, it will be taking you to the mid. How you can take an example, like let's say you want to calculate a mid between 4 and 8 index, and then that will be 4 plus 8 by 2, that is 12 by 2 is equal to 6. So 6 will be in between this, right? So that is what we are calculating. So this is one way. But in programming, if you add two numbers, there is a chance in CPP or C language that it might exceed the value integer can fit in. So usually people do, at the time of calculation of mid, do one thing, let left be there, and you need to add right minus left by 2. So what this actually does, here if you see 4 plus 8 by 2 you have done already, right? So what you can do, let's take 4 common, then not common, let's take 4 from each, means 4 we have taken out, and now here it will left with 0, here it will left with 4, and if we divide it by 2, then it will give 2. So 4 plus 2 will be, means this section is 2, right? 4 plus 2 is 6, so that's also give the same number. That's why we can use this formula as well. Let me just highlight this formula that we are going to use. Now few more constants you need to take care, else your algorithm will not work. So what are that constant? Let me write it here, like left of your uh, array, this, and this is right, needs to be equal to less than equal to right. If that right goes beyond left, means let's say right is currently equal to left, it means that, but we are at some index, let's say this index, here you can see here in this index, and left is also here and right is also here. If right goes beyond it, that means this in this array our solution does not exist. But if left and right are at the same position, it means we have just one element left that could give us a solution, right? So that's why in constraint we need to use this constraint. Now let's keep bundling all this into one chunk. Now we have an array, let's say we have an array 2 4 7 9 16 19 27, and its index are 0 1 2 3 4 5 6. Okay, now our task is to search for, let's say, element 19. How we are going to search it out, right? So we'll be searching that 19 in between 0 to 6, right? Left is 0, right is 6. We need to search it in between left and right. So our initial range is 0 to 6, and target is 19. Okay, now what next? We need to find mid. Range mid. Mid is equal to, you can calculate like left plus right minus left by 2, or you can for simplification use just the simple math, like 0 plus 6 by 2 will give you third index. Now go to third index and check third index and check if 9 is equal to 19. No, right? 9 is not equal to 19. So what we are going to do, check here, is 9 equal to 19? No, right? No. So what next? Now we decide whether we can divide our search space into two half. That is, we are always sure that 9 will be in the right, sorry, 19 will be in the right of 9 always, right? So what we are going to do, we are going to consider that our range will be from third index, not third index, actually third index is 9, we didn't got that, means we are not able to uh, the element which we actually got is 9, not 19. So from 4 to 6 our search space will be, if we'll be considering 3, 3 is redundant for us. Most of the time people make the same mistake, like they consider 3 as well. Don't consider 3, because that will be not part of your search space from now onward. There will be cases where we need to include 3 in other binary search variant that I'll cover in next video or some other video. Okay, now we are able to divide our range uh, into half, that is from fourth index to sixth index. What next? Now we need to consider what will be the mid. Mid will be 4 plus 6 by 2, that is 10 by 2, that is 5. Go to fifth index and check if that exists or not. Now value at mid is equal to our target, right? So this is something from where we can say that value is present. Value is present, right? That we can surely say. Now that is something means now we have a pseudo way of solving it. We know what the algorithm will be. Now it's just the case that we can implement that out, right? Let's go here and try to implement same thing. And your stuff means few stuff will not few stuff. Yeah, just let's write it. I was explaining the solution. Let's code it, and then if there will be few additional points, I'll mention that out. Okay. Now what it does says, given an array of nums which is sorted in ascending order and an integer target, write a function search target in nums. If target exists, return then return its index, otherwise return -1. Okay, so now we know we need to search for that element. If that element is present, we need to return the index of that element, else we are going to return -1. Now left index will be 0, right, from where we are going to start, and right index will be length of nums -1. Means this is our search space where solution will be present, means may or may not, right? Now while left is less than equal to right, we are going to perform some operation. What are this operation? We need to calculate mid element. What the mid element will be? Mid element will be left plus right by 2. Now we need integer division in Python, so that's why we added that. In Python there is no problem, like we are adding left and right and it will be overflow, so that's why I can use this formula. But what you can do is you can do left plus right, right minus left by 2, that is also the same. Now if value at mid means nums of mid is equal to target, right, then we are going to return that index. What will be that index? The index will be mid element, right? So we are going to return mid. Else if nums of mid is less than target, if it is less than target, what we are going to do, our search space will be shifted to rightward. So what we are going to do, we are going to update left to what number? We are going to update left to mid plus 1, right? Else what we are going to do, we are going to update right to mid plus mid -1, not plus 1. Means let's say we are at center and we want to decrease one step to the mid, so we are going to update right as mid -1. If this completes and we are not able to get any number, means we are not able to return any index from here, then what we are going to do is return -1. This is a basic binary search algorithm that will work, right? Now I think this will work. I have done it multiple times, so I'm just adding it at once. Yeah, that worked. Now a few things to mention, like why I'm making this video. I'm making this video to help you and myself for interview, right? So yeah, one more thing, I'm following Striver's A to Z sheet. Uh, Means he's one of the good tutor for DSA. Anyone can consider that out. But uh, yeah, I think you can. It's okay. That's it. I'm following him. That's the purpose of video. And yeah, I will be bringing similar videos, and I'll be helping you solve these questions in just two if else, not right if else if and else. That we'll consider in next video. That's it for now. Yeah, thank you so much.